Over the past 4.5 years, one of the great privileges that I've had is that I have regular with Geert Vanden Bossche. And it's always complex, it's always deep, but in reality, what he is doing is analyzing the science and trying to make sense of the complex. One of the challenges is trying to predict what is going to happen next. But one thing is for certain, Geert has always been concerned about where we are and where we are going. This could be one of those seminal interviews, like in March of 2021. I don't know. But every time I speak to Geert, I keep hoping that maybe this is not right because the implications are so serious. But without further ado, let's see if we can add Geert to the stage. Hi, Geert, how are you? As usual, do you mind just doing a quick introduction of yourself to the audience?
Yeah, sure, Philip. Thanks for having me again. I would say, my name is Geert Vanden Bossche, and I got trained as a veterinarian, a veterinary surgeon in Ghent in Belgium, and after my education in veterinary medicine, I specialized in immunology, molecular biology, and virology. That was basically at the Robert Koch Institute in Germany, and then I went on to do a PhD in the German-speaking languages that is called habilitation in virology and environmental virology. And after about 10 years in academia, I then switched to the industry where I worked with a number of vaccine companies like GSK, Novartis, and also Solvay Biologicals, where I was, I've worked in several different departments, project management, quality control, and also the research department. And I was primarily responsible for alternative delivery and also adjuvants, the adjuvant science. This is what I specialized in, I would say, GSK and also in Novartis. And then again, after about 12 years in the vaccine industry, I then moved to the Bill and Melinda Gates Foundation, was a senior program officer senior program officer in vaccine discovery. And I then also, after 3-4 years at the Bill and Melinda Gates Foundation, I founded my own company, which was specialized in new immunization methods based on natural killer cell activation. In the meantime, I also worked for Gavi, the Global Alliance for Vaccine Immunization. In Gavi, was there the senior program officer for Ebola. So this was back, I think, 10 years ago when we had the Ebola crisis in West Africa, and where I was involved in the interactions between the vaccine industry and Gavi, also WHO, with regard to the deployment of a vaccine against Ebola in those West African countries. And then finally the COVID pandemic came along, and I immediately realized that this was something serious with regard to a challenge for the vaccine industry. When I heard WHO was going to tackle this with recommendations for mass vaccination, I got immediately alerted. I had experienced some irregularities in terms of control management of viral infections by global health organizations that basically know some theory but have no clue about the practice of vaccinology. And ever since the beginning of the pandemic, I got deeply involved in analyzing essentially the dynamics of this pandemic, the interaction between the immune system and the pathogen at a population level, and in a context where, of course, the immune response is heavily influenced, not to say compromised, by the mass vaccination. And I followed it. I followed because this was unprecedented. We never had a pandemic where human intervention was so incredibly massive, was so incredibly large scale, which made which turned this pandemic into a real immune escape pandemic with many, many mutations going on all the time. And finally, I have recently put my thoughts together and put this in an article that now shows what will be, at least I'm very much convinced of, the end game of this pandemic, and how, in fact, there will be only one winner, which is nature, I would say. I stop there, Philip, because we still need to have some discussion on the different topics you would like to highlight. Over.
Yes, so I think it's important to acknowledge here, Geert, that you have vast experience prior to the pandemic, and you have vast study, academic and observation-wise, during the pandemic. So it would be foolhardy for anyone listening to not at least take into consideration seriously your thoughts. And that's all I say to the audience. I know many people understand what I mean and they listen to you, but then there are a lot of critics out there who don't necessarily agree, not realizing that this is high level stuff. What we're going to be covering in this session is that we're going to be talking about this article, When the Trojan Horse Becomes the Elephant in the Room, and we are also going to be linking it to your image. I'll show it afterwards, so to speak, to understand what is going on. The first thing that I would say, and I've got this from a presentation I did about the imagining the Hivicron, which is your concept, is that this is what we are dealing with in terms of the Omicron related variants. It is a monster of, ongoing, new variants. This is just not stopping. And effectively, you seem to be saying that in the same way that we got an Omicron variant that just seemed to jump out of nowhere, we are going to have another variant just take a quantum jump to another phase where it will not only become infectious, but also highly virulent. Is that essentially what you're saying?
Yeah, that is essentially what I'm saying, Philip. I'm always saying the element that is missing in most of the analysis and interpretations is the immunology. Because when you, and I will talk briefly about this Omicron jump and the Hivicron jump that I'm predicting. When you look at it at the beginning, before Omicron, the virus became more and more resistant to the neutralizing antibodies. But that kind of immune escape of the virus was what we call antigen specific. It was targeted at specific epitopes that were eliciting neutralizing antibodies. That's what we call antigen specific. When we had the jump of Omicron, the virus was doing something very spectacular because Omicron enabled the virus to have the vaccine breakthrough infections. And as a result of the vaccine breakthrough infections, we all of a sudden got immune responses that were much broader, remember that, global health authorities, etc., were crying victory, were excited, because not only were the vaccinees now protected against the circulating variant, but also against a number of other variants, right? Of course, I knew already, but people, this has now been documented, that those immune responses, also relatively broad, were less functional and were in fact promoting further immune escape. But that is not the point I want to make. The point I want to make is that here the virus all of a sudden expanded its arsenal of immune escape capacities by escaping the immune system in an antigen non-specific way. Because now there were immune escape mutations in epitopes that were much larger and that were shared amongst a number of variants and even other viruses. So it was no longer antigen specific, it was antigen non-specific. It was also, let's say, broadly cross-reactive. To go one step further, what the virus can still do is that it now can make immune escape not antigen non-specific, but non-antigen specific. So that means it can now, escape the immune response in a way that is no longer related to specific antigens. So when I'm talking about, for example, a virus that is adding some sugars on its surface, that can help the virus to completely bypass the antigen presenting process. The antigen presenting process, generally operated by antigen presenting cells, is what is stimulating B cells and what is stimulating T cells in ways that are antigen specific or maybe antigen non-specific. But there is still one major leap that the virus can take, and that will be, for me, Hivicron, where it can, if all this immune pressure that has been put initially by antigen-specific immune responses or by antigen non-specific immune responses, for example, broadly cross-reactive T-cell responses, and you know what this is, Philippe, because you are interested in autoimmunity. The broader you have these immune responses, and the more they are directed against also conserved epitopes, some of these epitopes may resemble self-antigens, you can get autoimmunity. But now there is still one other possibility, and that is to completely bypass this antigen-presenting cell that is responsible for at least some specificity of the immune response, and that can completely, if this is antigen-presenting cell is completely bypassed, that means that you will escape from all the immune responses that has so far been initiated in people who got exposed, vaccinated, non-vaccinated, etc. And
I just wanted to jump in there a minute, Geert,
yeah,
because some of this is quite complex. So I'm trying to get my simple mind in place. The way I describe this virus, a key to your house, and it will open the door and it will go in. Okay. And when Omicron came along, because the vaccines then put kind of a lock on the front door, instead of going through the front door, it just climbs through the back window and it still gets in. You're almost saying that the new variant will just walk through the door where there is just no defense in terms of the immune response. The immune response no longer has the ability to respond when the new variant comes. Is that related to the variant, or is it related to the immune system of the person?
It is related to the pressure that the whole population, you have to know, because of the mass vaccination, there is a kind of like a shared immunological landscape in a population. Not everybody has exactly the same immune responses, but there is a lot of common denominators. And that is putting the virus under pressure. Why? Because if there is this common denominator, if the virus gets transmitted from one people to the other, it will very regularly encounter this hostile environment. And this hostile environment that is represented by, let's say, the majority of the population that is always mutating, of course, will variants that can thrive and have a fitness advantage in this hostile environment. And that is, but these are still all adaptive immune responses. Remember, the vaccines are primarily stimulating adaptive immune responses. And everything we're talking about, the antibodies and the T cells and the jumps that I was talking about, antigen specific or antigen non-specific, all this relates to the adaptive immune responses that are, for now, still to some extent protecting the vaccinees. What I'm talking about is a trick that the virus will apply to completely bypass, circumvent, sideline this whole spectrum from adaptive immune responses, because it will no longer taken up by antigen presenting cells. And it's important to say, I know you have a comment, Philip, but just like to add that at that very moment, it's the innate immunity that will play a critical role. And because what I'm talking about is also applies for the unvaccinated, of course. They can not rely on their adaptive immune system either, because the virus is not just playing these tricks. You know, it has been let's say the majority of the population having this vaccinated immune status have been educating the virus to adapt to that situation. But these adaptations, when it circulates and it hits the unvaccinated, it will also subvert their adaptive immune system. But for them, it's of course much less of a problem because they have trained their innate immune system. The vaccinees could not do this because the vaccines didn't do that. And when Omicron came with the vaccine breakthrough infections, which were blowing like, very rapidly through the innate immune system, there was no opportunity to train. And therefore, when their adaptive immune system gets now completely bypassed, they are like naked, in front of a virus that will replicate, will destroy cells, and will just disseminate in the body if there is no immune defense left.
So this brings me to this image that I had found very interesting, where you were highlighting that the speed of the variant transmission is getting faster. Is this part of what you're talking about, where that evasive variant comes along? Is it because this process is speedy, accelerating, why it occurs?
Yeah, well, I'm trying to explain this in a very simple way, but this diagram shows, and I'm anxiously looking forward to the next one, because CDC is only issuing this once a month, where before, in the past, they were issuing these diagrams, very interesting, every second week. So what you see there is clearly that the contribution of circulating variants to the overall landscape, the viral landscape, is changing, and that you have very regularly a circulating variant that all of a sudden starts to dominate. And then if the next one comes up, it goes even faster. So there you see, for example, 6 months, 4 months, I'm comparing columns that are comparable in terms of achieving the same height of the column. But what in fact this means is that you have mutations, and that is what my article is about. You have, first of all, let's say that now primarily the immune defense of the vaccinees is relying on T cells. And that is the reason why I don't need to explain to somebody like you, Philippe, that these chronic inflammatory T cells are now also responsible for a number of these diseases that we are seeing: chronic inflammatory T cell responses, chronic infections, autoimmunity, etc. And so what the virus can do is that, because on one hand side, people don't realize these chronic infections is kind of like a nasty situation for the virus, in a sense that during the chronic infection, you have per unit of time, less virus shed. If you have an acute infection, you have a lot of virus that all of a sudden is shed. Here it's more prolonged, but for the same unit of time, you have less virus shed. So it is like hindering transmission of the virus. So the more chronic infections you have, the more you have pressure on the transmissibility of the virus. So the virus needs to do something about this. And what it is doing right now is that it is mutating, it is incorporating mutations precisely in the epitopes that are responsible for stimulating T cells that have an antiviral effect by virtue of their antiviral cytokines that they are secreting. And so the variants that do this get, of course, a competitive advantage. So I should say the other way around. When these mutations happen, and mutations happen all over the place all the time, when mutations happen that have changes in the epitopes that are responsible for triggering T cells with that produce antiviral cytokines, then in the context of reduced transmission and pressure of the population on viral transmission, these mutants will get a competitive advantage, a fitness advantage. And that is what you see when they start, of course, to dominate. So these guys, by becoming dominant, they will, of course, transmit to, they will increase the transmission. So you will have new cases of chronic infection, of long COVID. And that is what we are seeing right now. We are seeing that in the population, the number of cases of long COVID are still increasing in highly vaccinated countries. So you can imagine that if one of these variants occupies a bigger and bigger part in the landscape, in the viral landscape, then ultimately it will be this variant that is going to infect the majority of the people. And why is this important? Because why is this variant dominant? Because it has the maximum of mutations in these T cell epitopes that will in fact hinder T cell defense against the virus. But of course, there is a limit to that. And the pressure on the virus is diminished as long as you have co-circulating variants that occupy a fair part of the pie, but they are doing less well than the dominant variant that has, better or more mutations in these T cell epitopes. If you have others that cannot compete because they have less mutations that hinder T cell defense, then the pressure on the virus will be less because the transmission will still be relatively good. Now, if the variant starts to dominate, that will in fact decrease the defense of the T cells. and the immune pressure will very much increase. And that is where I'm saying, when this evolution, when you see that it goes faster and faster, that is one thing, and that the final result of that dominance will be a much bigger part of the pie, then there is the pressure can no longer be diluted, and there is more and more. Yeah.
Just to capture you again. So I've while you're talking, I was thinking of some images here. This is my image of the army of the immune system. It's just an army. And I consider the T cells like the Air Force for whatever reason. So in effect, what you're saying is that this T cell response is no longer going to be able to be effective because the variant will evade it. It is already not producing accurate missiles with the antibodies anyway, because it has evaded it as well. And they have limited natural killer cell response as well. Is it that so all of these here are not able to deal with this variant?
They are not able to deal with a variant, but every time you have reinfection, and the virus is circulating and people get exposed over and over again, you will have more and more stimulation of the T cells. You will have more and more production of cytokines. So the effect is, in fact, the defense is kind of like improving because you have more stimulation of T cells. So that, and if more people get infected, more people are going to do this. More people are going to develop these chronic infections, which ultimately will increase the pressure on the transmissibility of the virus, because the immune defenses become better and better, but they are not optimal. They cannot eliminate the virus. So remember, every single time that you have a strong immune response that is subfunctional, you generate a lot of immune pressure on the virus. And so that is what, despite the fact that you have more and more cases of long COVID, so people could say, well, we have high viral load and we have more and more cases of long COVID, so the virus can replicate and it can transmit. It should not become more virulent. No, that is very tricky. Despite the fact that you have more cases of long COVID, because more cases of long COVID, of chronic infection, more cases, so the frequency, the prevalence of long COVID increases in the population, you will have more pressure from the T cells on the transmissibility of the virus. And, that leads the virus to escape and to paralyze, so to say, some of these T cell epitopes. And that is in fact why at that moment, the variant that gets selected in this environment will, and that has a maximal of these mutations in the T cell epitopes, will become dominant, right?
Oh, this looks like this picture. So eventually it almost neutralizes this T cell. This is my imagination as usual. So you have to work with me on this, Geert. And so these T cells, which had been responding before, when that variant evades it, they technically become non-functional. Is that about right?
Yeah, well, the T cells, they they are not optimally functional. Yeah. So, but they are not paralyzed. I mean, people always think the T cells get paralyzed, they get silenced. No, they don't get silenced, because otherwise there would be no immune pressure. And there is more and more of these T cells that get recruited, and they can do a pretty good job. But what they cannot do is they cannot curtail, they cannot stop the transmission. So now the virus is in difficulty because the transmission diminishes, but it can still be transmitted. So automatically, variants, mutants that can do something about this T cell defense that is annoying the virus, they will have a competitive advantage. And those are the ones that we see are now dominating. Unfortunately, WHO and all the mutation trackers are, in my humble opinion, completely missing the key part of the story, because they continue to sequence the spike protein and see whether there is differences between those variants in the spike protein, etc. Whereas these changes in the T cell epitopes are primarily located in the nucleocapsid. And if you don't sequence those parts of the virus, you will completely miss what's going on, because you will start and continue to focus on minor changes, what we are seeing right now, minor changes in the spike protein, whereas you see spectacular changes in how the picture of the landscape is evolving, how new variants all of a sudden start to dominate. It's going very, very fast. They increase their part of the pie within just a few weeks. This cannot be explained by just minor changes in the spike protein. But
Okay,
if you don't,
just so that to help everybody here, I've got this picture here of the virus. And so what you're saying is that it's no longer just spike protein transitions that are causing the immune pressure, but actually changes to the nucleocapsid protein inside the virus because of the T cell targeting. And this is what is increasing the risk of a Hivicron, because no longer is it just spike, but spike and nucleocapsid at the same time.
Yeah. And so the unfortunate thing is that, of course, these are now new variants. These are, in fact, new variants because they have critical mutations in the T cell epitopes that the previous variants didn't have. But as nobody is looking at the sequences, and as of course there is always also some sequence difference in the spike protein, it's not that it shifts from one protein to the other and that you don't see any changes in the spike protein. But the only changes, if you analyze these new mutants that have the changes in the T cell epitopes and you only look at spike, you will see, of course, some changes in the spike, and you will say, oh, those are different from the previously circulating variant. And so now all the increase in infectiousness and the dominance, etc., is, so to say, attributed to changes in the spike protein. You see what I'm saying?
This is okay. Now I'm getting where you're going. This is a very important point. So
you're completely missing the picture here.
Yeah, so you are saying that the most critical changes that are occurring in these variants are actually in the nucleocapsid, which are T cell responsive, because you can't, only the T cells can target the nucleocapsid because they have to get inside the cell in order for them to be picked up. So because we're not measuring that, and because we're only measuring the changes on the spike protein, we are completely blind to the fact that this transition is occurring.
Yeah.
Right. No, I see. And so in effect, so the question would be then, even if they were measuring or studying changes to the nucleocapsid, would it be helpful at all?
Well, I mean, it would be helpful. Of course, Philip, it would be helpful, because right now, when I do this analysis, I think that the dominance and the change in the landscape is purely due to changes in the infectiousness, the intrinsic infectiousness of the virus, which is largely determined, as you know, entry, etc., and the interaction with the receptor by the spike protein. And so I don't even realize that something is going on with the T cell epitopes. And therefore, if there is something going on with the T cell epitopes, it is because there is, some negative effect of these T cells on the transmission of the virus. Otherwise, the virus would not massively select these mutations in the T cell epitopes. So we are completely missing what this changing picture is coming from. And people are still saying, oh, yeah, this is the spike protein and there is some changes. And see, this one mutation is different from that one. This is so minor. The big picture that we have a whole series of new variants that have changes. Remember, in T cell epitopes that are normally highly conserved. Of course, the spike has also T cell epitopes, but these T cell epitopes are pretty variable because, they are often T cell epitopes for T helper cells that assist the production of antibodies that need also to be variable, the variability of the spike protein. But the T cell epitopes that are really conserved, these are primarily nucleocapsid. And I'm not saying that they are only looking at spike protein. To some extent, they look also at other proteins, but they only look at other proteins to the extent where they think, WHO and others, that it is important, for example, for resistance against neutralizing antibodies, for infectiousness, for certain clinical symptoms, etc. So they have a number of criteria that have to do with resistance to neutralizing antibodies, with infectiousness, with diagnostic, for example, and those proteins and those sequences will be analyzed. But they have no clue right now that there is incredible T cell activity. That's why we get this chronic inflammatory. This is due to the T cells. And that the virus, that it is a very nasty situation for the virus because the cytokines, antiviral cytokines, interferon gamma, etc., are produced like hell. I mean, the virus needs to do something about this or not going to survive. And what it is doing is that it is, in fact, damaging these T cell epitopes that will precisely trigger the T cells that are going to produce these antiviral cytokines and that to a large extent are situated in the nucleocapsid. So if you don't understand this, you have no clue what's going on right now. And you still think, oh yeah, the virus is changing a little bit of amino acids in the spike. And that is what explaining the whole thing. I mean,
can I clarify something here? Because I just tell me if this is right. So when we think of the T cell response versus, say, the B cell antibody response, the B cells, I consider the bullets or the artillery, they're firing at a distance. But the T cells, when they see a cell with, say, a nucleocapsid protein on it that they recognize, they don't just target the virus, they destroy the cell with the factory. So they kill the factory itself.
That is not true.
All right, okay.
But
because
no, that is exactly such a misunderstanding, Philip. That's why I'm talking about, we got a notion sub-neutralizing antibodies, right? Sub-neutralizing antibodies are antibodies. These were typically the antibodies that were generated when we had Omicron, right? We had all of a sudden antibodies against a broader spectrum of B cell epitopes. But they were sub-neutralizing. That means that the functionality in terms of the neutralization was not optimal, hence why they declined very rapidly, hence why the affinity for the virus was not optimal. That is what we called sub-neutralizing antibodies. So they did not do a very good neutralizing job. Here we have the same with the T cells. In an acute self-limiting infection, that is what SARS-CoV-2 originally generated, acute self-limiting infections. You have a cytotoxic T cell response that is killing the virus-infected cells. Once we got Omicron and the vaccine breakthrough infections, I told about this immune refocusing. Luckily enough, some people have now been publishing this, that all of a sudden you have now immune responses against epitopes that are more conserved, and hence you have broader cross protection, so to say, But these T cell responses are also suboptimal. That means the antiviral cytokines will ultimately kill part of the cells because they will have an impact on the viral production, etc. But they will not eliminate the virus like in an acute self-limiting infection. That is why we have these chronic infections, because the T cell activity is suboptimal. If it were optimal, you would not shift from acute self-limiting to chronic infections, right? So are these T cell responses still very much annoying for the virus? Yes, of course. They put the virus under pressure. They diminish infected transmission. But are they killing the virus? No. There is sufficient virus left that the transmission can continue. And, transmission continues. That means replication continues. That means mutation continues. That means there can be a selection of the more resistant, the most resistant variants. And those are precisely those who are going to make the T cell responses weaker. And that are the mutations we are talking about. So there is a lot hidden behind the graph that you just showed me, and that is not understood, and where everybody is looking at this, but nobody is trying to draw any conclusions, because they don't understand the immunology that is behind and the dangerous immune pressure that is increasing. Because at the end of the day, you have to understand, Philip, the picture that you're seeing at the end, the column on the very right, shows you that more and more the viral landscape is taken over by a variant that is doing a fairly good job in inhibiting these T cells epitopes to an extent that it has gotten a competitive advantage over the others, so to say. So that
And just to clarify, which image are you talking about? This one?
Yeah, this one, of course, this one.
Yes.
Where you see this is not blue. I don't know exactly what this color is on the right hand side.
This one.
Yeah, exactly. Well, that is the prediction or the forecast for the end of August. Yeah, we are already September. That's why I'm saying it's the annoying thing that they are no longer publishing this on a regular basis. But you see that to reach the height of that column on the left hand side, the yellow arrow. Do you see the yellow arrow? That yellow arrow has the same length as the yellow arrow 3 columns exactly. And so now you see how much time do I need, starting from the same level, orange, and the same level, this kind of gray-blue, to reach the same length for this arrow. And then you see in the first, it was 6 months, now it's only 4 months. And also the maximum column height that was achieved by the previous variant is the first arrow in yellow. You see the next column is diminished already. But here on the right hand, the second arrow on the right hand side, it's not going to diminish. You see what the forecast is it's going to further increase. So the increase is much more dramatic and it's much shorter. And so that will be increased to an extent where ultimately the whole population will be dominated by, I call this now a T cell epitope variant that is kind of like inhibiting the T cells to, give virus transmission a chance. But what will happen is that this dominating strain will infect more and more people. So you will have more and more chronic cases of long COVID, chronic inflammatory disease. You can follow this. You can monitor this. How, and I'm saying for sure, how the prevalence of chronic inflammatory T cells of long COVID is going to increase still. And when it does so many T cells are activated that the immune pressure on the virus increases. And if that concerns the one variant that has already a maximum of these mutations in the T cell, well, there is no other way for the virus than to use a completely different trick, like Omicron did in the past. There were more and more neutralizing antibodies, making life so difficult for the virus. The virus, all of a sudden did this Popeye trick, where all of a sudden a completely new kind of mutations occurred that enhanced infectiousness. Now, the only trick that the virus can apply here, it's no longer with the proteins. It's no longer with the B cells epitopes. We had this story with resistance to the neutralizing antibodies. Now we had almost a story with resistance to these T cells. The only thing it can now do is to completely bypass this whole array of all possible and impossible adaptive immune responses. And the only way it can do this is to bypass antigen of the immune response in glycans. And there is evidence for that. You see in a publication, glycans, that this is non-antigen specific. It has nothing to do anymore with B cell epitopes, with T cell epitopes. It's just having changes on the surface that says antigen presenting cells, not interested. I don't need this.
And so in that situation,
and that is what silences ultimately the adaptive
immune system. Yeah. So that's what I've been describing almost as a viral. The viral sepsis is not quite the accurate term, but unchecked replication of the virus throughout the body. Now, one of the interesting things about this virus compared to, say, the influenza virus is that it is not as cytopathic in terms of destroying the cells that it infects. So this is why I've been trying to think carefully. When it bypasses that immune system, how does it present in terms of clinical disease? That's the question that this is where I was trying to work out. Okay, if it has bypassed the immune system, what is the clinical presentation and how does it relate to where that person's immune system or their health was? Because it must be different in a frail older patient compared to someone who has comorbidities, compared to someone who had previously been fit and healthy.
Well, it's almost like, it's very similar to asking the question what happens to a country where you have an invader, you have an enemy that invades the country, and you have no defense system in place. What happens, right? I mean, and that the virus would be less cytopathic and, less virulent, I would almost say, than influenza. Remember, this virus has now adapted to become highly infectious, right? That is also what we have seen at the very beginning with the Wuhan strain. First of all, before clear-cut resistance to neutralizing antibodies occurred, the virus became more infectious. We had from alpha, we had beta, gamma. All this was before the mass vaccination, right? Virus became more infectious. So now, after Omicron, of course, I mean, the first move that the virus did again was to become more infectious before it even shifted to the T cell immunity, to rely, I would say, before the hosts almost entirely, which is the case right now, relies on the cytokines, interferon gamma, etc., secreted by the T cells. So when this virus now, in terms of intrinsic infectiousness, is way more infectious than the initial strain or the Wuhan strain, right? There's also the reason why, for example, the unvaccinated, despite the fact that they have trained innate immunity, a lot of unvaccinated people right now are getting ill, not severely, rather mild. It's gone after a week, 10 days, sore throat, some are coughing, because the high infectiousness of the virus. So if you let this virus go into cells of your body with no immune defense in place, innate immunity, in many vaccinees, not in all, of course, biology is not black and white, but in those who have not trained their innate immune system, and you come with a virus that is completely capable of bypassing antigen-presenting cells and the whole adaptive immune system that follows, I mean, this is just an accelerated, a hyper-acute viremia, disseminated, yeah.
So when I think about it,
Yeah.
because this is
Sudden
now,
death. Sudden
yes.
death.
So this is the question. Now, what I'm observing is that at the moment, the symptoms around an infection are so subtle. It literally, you have to quiz a patient to say, could you have been exposed? Because all you had was a little bit of fatigue and a headache. And then weeks down the line, they are presenting with unusual clinical presentations.
Yeah.
Is it possible? And so this is now where I want to think about this Hivicron. Is it possible that it is already here? It's just that the clinical presentation, because this is the bit with regards to the virulence in terms of presentation, because we are almost looking for a rapid deterioration. My instinct, based on what I am seeing, is that a lot of people no longer have an immune system to fight. It is their immune system is so exhausted that even when Hivicron comes and is evaded their immune system, the T cells, there is no mounting response. And they just feel sick, get sick, but it is just a wind down. I mean, it's really unusual. That's the only thing I can say. And my instinct, which is why I did this presentation on the Hivicron, is that I asked myself the question, is it possible that it is here already?
No, for me, it's not possible. And I think, and it's the first time that I'm really going to say in an interview what I think. People cannot imagine when this happens, when this change happens, like with Omicron, it blew everyone away. It blew everyone away. It was just that, the infectiousness increased dramatically, but luckily enough, we had protection against severe disease. I explained this in my course, how this was probably due to IgM antibodies, and also later on by the fact that the T cell immunity came into, became very, very operational. But here you have to imagine that this change will be even more acute. I'm talking about hyperacute, and that it blows through a body that has no immune defense. So there's nothing comparable to what we have ever seen. So I want to be very, 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 very clear at this, and also, I mean, people, we will be able to analyze this. We are no longer talking about SARS-CoV-2. We are talking about a completely new coronavirus that will have unusable glycan chains on its surface, and that in the meantime, of course, has already undergone a lot of changes. We have been talking about all the changes in the B cell epitopes. We have been talking about the changes in the T cell epitopes, etc. We are coming up with a completely new virus. But as I'm always saying, people will be caught by surprise, because if you hear experts talking right now about what the virus is doing, you see that in several countries, for us, to the extent that the data are still published and that monitoring is still done, you see an increase in the viral load in wastewater. And people say, wow, that is, the virus is transmitting and is propagating pretty well. So the more it is infectious and the more it spreads, the less it feels the necessity, that's their reasoning, to become virulent, right? And I'm saying, behind this high viral load And behind the increase in the cases of chronic infections and long COVID is hiding a tremendous immune pressure on the transmissibility of the virus. This seems contradictory, because you have high viral load, and you have a problem, the virus has a problem with transmissibility. Of course, because the vast majority of the viral load are cryptic variants. These are variants that individuals are producing, and many of them, because we have more and more cases of chronic COVID, so many are producing cryptic variants. Those cryptic variants are only sporadically detected because their number is so low, so to say, of one specific, and they are not transmissible because they don't share the commonalities that, for example, in the T-cell epitopes, that variants should be sharing in order to be transmissible. So a big chunk of what is detected in the wastewater is completely irrelevant for the understanding of the dynamics of the virus, because these are cryptic variants. And therefore, people think we have a high viral load, virus is spreading pretty well. Where does Vanden Bossche come with pressure on viral transmission? Look at this, it's fantastic. They're completely, missing the boat here, and it is complex. I'm the first one to say that it is complex. It's extremely misleading. Misleading.
I want to pick your brain on something here, Geert, because as I said, I was really reflecting on the concept and the principle with regards to Hivicron. I came across a paper here, and in this paper, it was looking at, just as you described, a chronic COVID infection in an immune suppressed patient who was on medication for immune suppression. And what stood out to me was that from the initial onset of his infection to when he eventually died of respiratory failure was about 14 months. Okay. In this case, he clearly, because he was on a lot of immune suppression, so his immune system was not working properly. And so this is part of the question with this virus. It will eventually take out the organs, but it seems to do it very, very slowly. Do you think that the variant you are talking about is going to be more like that influenza kind of variant, very cytopathic, just destroying the cells that it infects, and therefore leading to severe viral disease in a short period of time?
Yeah, of course, because the image and the publication you were showing, Philip, I mean, these are all kinds of mutations in epitopes that are not shared, that are not broadly shared, and that are individually different. The mutants that you will find in this patient who is chronically ill, underlying disease, immune suppressive therapy, and whatever, the mutants that you will find that this person will produce are very different from the mutants that another person in a similar situation will produce. The selection has been done intra-host, within the host, during the replication. What we are talking about are variants in epitopes that are shared, because those will have a transmission advantage because they are shared. This will be supported, their transmission will be supported by a large population, right? These are, in fact, not intra-host variations. One of the mutants that people like this immune-suppressed patient will produce, one of the many mutants is, for example, one that happens to have a mutation that is inhibiting cytokine-secreting T cells in a shared epitope, this mutation. And this one, because it is in a shared epitope, this one will have a selective advantage in the terms of the transmission, because it will, in a broad population, it will get this fitness advantage. And therefore, it will replicate much, much faster. Exactly. you see, that is the diagram that we were looking at, how fast it goes. The mutants that we are looking at there are not the mutants that have the changes in the spike. Those are the ones that are now making changes, selecting mutations in conserved T cell epitopes that are shared amongst epitopes that are shared amongst several different variants. So when that happens, they get a transmission advantage in the population, not within the host, in the population. And this is supported by the entire population, by the shared immune status of the population. And then you see it goes very, very fast. And it will still go faster. I'm really curious to see the next diagram, if we will still get to see it. I don't know. But this is going fast, yes. So this is not comparable to intra-host selection of mutants that are individual species, the transmission of which is not supported by the collective immune status of highly vaccinated populations. And therefore, this takes, of course, a long time. This is the host himself struggling with its immune arsenal against this particular variant. So this is a completely different situation. So yes, it will go fast because we are always talking about collective population level immune pressure on the virus. You know, I can only give the example, Philip, of Omicron. It happened overnight. Nobody was expecting this, right? And this time, for me, it will even be much faster, because what I'm saying is that when Omicron came, there was still immunity left. When a virus is now, or a variant, will bypass, the adaptive immunity in full, completely sideline the adaptive immune system, you can imagine this is a story that will take, 12
Yes,
hours, 4 hours.
I think you're right with regards to what you said about Omicron. That really hit a nerve, so to speak, because as I was saying, when we looked at there's a preprint paper that has come out that has shown a dramatic transformation in the Omicron variant from the previous variants, where the mode of entry, the way how it infects, just suddenly seemed to change, and then it swept the world. And so when we think about that, then I would presume that this kind of variant that is being trained within a population, in highly vaccinated populations, should not therefore have the same impact in low vaccinated populations. Would that be about right?
Yeah, because this is, the most important thing to understand is immunity at the population level. So it begins with herd immunity. This is immunity at the population level, but it applies to all situations where there is a commonality, a common denominator between the immune responses that the majority of the individuals is developing in the population. And when we consider the situation now in a highly vaccinated population versus unvaccinated people, you have to imagine that the virus that is circulating in highly vaccinated populations, as you were saying, has been trained or has adapted to the hostile environment. And if 80% of the people are putting pressure on transmission, that is a hostile environment. So that virus that is going to ultimately be selected must overcome this hostile environment. And to do this, Philip, it will, just like Omicron, it will have to pay a certain price. And it is very clear that Hevicron will pay a price on its infectiousness. It will lose infectiousness. That is the price it is going to pay, because if that were not the case, you could ask yourself, but why couldn't Hevicron be selected already before? Well, the reason is that the environment has not been hostile enough to select Hevicron, because if it were selected before, the price on infectiousness would be higher than the competitive advantage it would gain in that hostile environment. I don't know whether you understand what I'm saying.
Yeah,
So
no,
it
I
can
think
only be.
yes.
Yeah.
Let me try and see if I can understand, and you tell me what is wrong, so to speak. So, in effect, there needs to be a period of time for the virus to continue to evolve in an environment where the T cells are applying the pressure. And it therefore requires time for a variant that would evade those T cell responses to then appear. And it can only happen in an environment where this is happening consistently across the population. Is that
Yeah.
about right?
Yeah, but don't say appear, you should say selected, because these mutants occasionally happen. They occasionally happen. So why are they not selected? Because in the current environment, the price they would pay, because of all these glycan changes, for example, the price they would pay in terms of infectiousness would be higher than the benefit they would have, the fitness advantage, in a less hostile environment. When the environment becomes more and more hostile, then this balance will change and the fitness advantage will be greater, even though the intrinsic infectiousness will diminish. And that is where comes in now the non or the unvaccinated. For the unvaccinated, the hostile environment doesn't play because they don't depend on this. They have their innate immunity. And the biggest enemy of innate immunity is a high level of infectiousness. That is why when the virus came in, Wuhan, for example, when you saw problems, for example, in regions where there was high infectious pressures, favelas, for example, slums, but also in our industrialized countries, where did you see these problems? In places where many vulnerable people were stacked together, like in elderly homes, nursing homes, etc. High infectiousness, innate immunity, has difficulty to cope with this. But now in the unvaccinated, the innate immunity got trained. And what I'm saying is that Hevicron will have to pay infectiousness. So it will become less infectious, in fact, in order to be able to develop these structures on the surface that will enable it to overcome the hostile environment. But that hostile environment doesn't play for the unvaccinated. For the unvaccinated, it will become less infectious. And that is why I'm even concluding in my manuscript, in my article, that I'm even very hopeful and positive for unvaccinated people with underlying diseases. Because if infectiousness diminishes, even though their innate immunity is a little bit weaker than those who were properly trained, they are better off than if they are confronted right now still with variants that are still have still a pretty high level of infectiousness. It's all
So,
complex
Geert,
and complicated. It's all connected. It's all, you have
yes,
to look at the virus and the immune system at the same time and the population.
so Geert, as we close this out, what do people do with this kind of information? So if you imagine that a lot of people similar, when we think of it in March of 2021, truthfully, that interview that was seen by a million of people, they recognized to be cautious in the pandemic, and the majority of them held back when it was time for them to be targeted with a vaccination, and that's what they thought. What are they supposed to do now?
Well, again, Philip, it's, I'm always saying if people have to bear one thing in mind, it is that the biggest issue is that we don't have herd immunity, which means that we cannot curtail, abrogate the transmission of the virus. And that, of course, we cannot stop immune escape, and that it will continue, and as we are currently seeing. So if you cannot stop this transmission, the only thing you could do is, of course, to kill the virus before it gets a chance to get into your cells. And to destroy everything, because there is no immune defense. So that is why I'm sometimes in a kind of mocking manner. I was saying what we need, in fact, is mandates for prophylaxis, for antiviral prophylaxis, that you have mass administration of antiviral prophylaxis, because the problem is that the virus continues to circulate. That is the result of suboptimal and dysregulated immune responses. If you have this at large scale, at population level, immune responses that are annoying the virus but cannot stop transmission, you have immune pressure on the virus, and the virus will not stop to evolve till the end game comes, where it completely bypasses the adaptive immune system, and it will, of course, do what such a virus will do, is that people who have no trained innate immunity and whose adaptive immunity is completely bypassed. It's the first time that I'm saying this so straightforward, but I mean, people continue to ridicule me. I mean, I want really to show that I'm very, very serious about what I'm saying after all these years, is that for these people, there's no chance. It's very, unless they would take antivirals. And will it still be time enough to take antivirals? Things will go very, very fast. I'm talking about a hyperacute phase of the pandemic, a hyperacute course of individual disease, namely sudden death. The number of casualties will be incredibly higher than we would have seen if we would not have had the mass vaccination. But on the other hand, I'm also saying biology is not black and white, and we need to distinguish between people who have been confronted with the virus before they were vaccinated, people who only got partial vaccination, people, for example, who got vaccine breakthrough infections. I think the people who clearly got vaccine breakthrough infections and people who clearly develop long COVID, these are definitely the people who are at higher risk. People who got vaccinated, for example, one shot, who got exposed to the virus before, who got not very severe breakthrough infections, maybe just symptomatic like a number of unvaccinated did. I mean, I think it will be less dramatic. So there will be a gray zone, but let's not fool ourselves, for God's sake. And let's not think that this is just that nature is just going to move ahead with a more and more crippled population. It will not happen, because the immune pressure is still there. It continues to, increase, because we get more and more chronic infections, and the virus will adapt. And that is so clear in my head. I'm so 2000% convinced of this, so that don't fool ourselves and say Yeah, we give every year vaccination an update of the antigen, and that will keep things under control, like it's doing right now. You see, because in terms of clinical symptoms, of course, there are these people with a long COVID, and there are still a number of severe cases, but all in all, a number of people, we don't see acute COVID cases almost anymore, right? They are diminishing. But this is still not a virus that has in itself causes chronic disease. And you see when, for example, the unvaccinated get exposed and they become ill, it's pretty acute. It's like before. The symptoms are maybe a little bit different, but they get a disease. Within 1 week or 2 weeks, it's gone. The chronicity of this virus is due not to its intrinsic properties of subverting antigen presentation, but is due to the continuous reinfections and to the continuous exposure of a virus that continues to circulate in the population. So we shouldn't think, we should not fool ourselves in the sense that we think, every year vaccinate, the more we are going to get this under control, and let's just fit this into the yearly vaccination schedule. You get the flu shot and then also the COVID, and this COVID thing that is now, spreading in the population has nothing, for God's sake, nothing to do with flu. And people are saying, yeah, it's becoming endemic. Come on, endemic. You got 3-4 waves during summer. Have you ever seen this with an endemic virus? And on top, it's never reaching the baseline, right? But when the peak goes down, it's not going back to the baseline. So this virus continues, and the determining factor, it's not the temperature or climate change or whatever. It's the hostile immune environment of the highly vaccinated population. That is what determines the behavior of the virus. We could go on for hours, Philip, but
yes, I realize this is some heavy stuff. And what I'll be doing is that I'll be reflecting on it and trying with some of my diagrams to try and break it down. But I take, as I said, for me, I take what you say as a risk mitigation strategy. The question is not whether it is right or wrong. The question is if it is possible. Let's look at it. Let's reflect on it. Let's try and see what can be done about it. And as you said, I agree with the fact that the ongoing circulation of the virus is unsustainable. Something has to give. And I in that sense, yes, the nature takes its course, because this becomes then a risk for the whole population, human and animal. It will not continue. So something has to change in order to stop this from happening.
So chronic infection, as you were saying, circulation of the virus, continued circulation of the virus is not sustainable. What that means is that chronic infection, as we are now seeing more and more, is not sustainable because chronically infected people continue to shed and to sustain the transmission. And that is not sustainable. So we cannot have simply, continuing chronic infections. That is just not possible. And we have seen that even with vaccination, we have no influence on this. On the contrary, so many people, the highly vaccinated countries, it's exactly in those countries that we are seeing this steady increase in, chronic infections and chronic inflammatory diseases, right?
Yeah. So thank you, Geert. As usual, heavyweight stuff. As usual, a lot of people have been waiting and asking for this conversation. I always end with the point, which is that I completely understand what you say. I can completely see the outcomes, but I keep hoping it never happens, because the outcome of that would just be horrific. But thank you again, Geert. And I'll just ask you to wait with me as we do our outro.
Okay.
All right.